Okay, good. So good afternoon to all. I'm Corinne from the BRGM, and I will have the pleasure to present the premise results on behalf of the whole premise consortium. So within the premise project, which deals with prioritization of emerging chemicals compound in soils, were involved the ESEP, Vitam Danbos and Arcadis, Deltares and RRVM, and the project was financed by the French Agency of Transition Ecology, the SPWay, the Ministry of Environment and Infrastructure of the Netherlands, and the OVAM. So first, the aim of premise. So when we wrote the proposal, the overall aim was to try to make a step further into bringing attention on CECs in soil. So the overall aim of premise was to build a robust and flexible approach, including designing a prototype in order to prioritize contaminants of emerging concern in soil and subsurface. So at first, premises included 3 goals. First, assessing which CECs are likely to be present in soil and subsurface. And for that, we undertook a couple of actions. First, we carried out an inventory of occurrence data of CECs. And we tested a fate module for CECs in order to understand how CECs was distributed in the different media. Second goal of premise was to evaluate which of the CECs we might find in soil, which may pose a risk to human health or environmental risks. So in order to do that, we developed a toxicological module in order to get toxicological values to define concentration thresholds of no effect. And we developed a risk-based prioritization scheme in order to be able to compare the CECs between each others. And the third goal was to propose opportunities for CECs management and policies and give recommendations for future R&D work. So to do that, we clearly state the modality of use of the prioritization prototypes, and we also involved stakeholders, which gave important feedback. So first, results on the inventory of CECs data occurrence, which was mainly targeting solid matrices, either soil or source to soil, sludge and manure. So first, in order to be able to do that, we really had to frame what type of substance we could include in this inventory. So we defined a contaminant of emerging concern as chemicals we were not regulated substance in soils. And then we came up with 11 categories of CECs, which was already referenced in the literature. And we decided to select only a few of these categories for the premise project, because otherwise the work was just tremendous for this one-year project, based on premise selections of relevant source pathway receptor schemes. As I told before, the prioritization skill is really based to select source pathway receptor schemes in order to carry it. And based on that, we selected 4 categories of CECs, which include pesticides, pharmaceutical, alkyl phenol, and PFAS. And a global inventory was performed on these 4 categories of CECs, i.e. substance name, number of samples, quantification, frequency. So you can see here an example of inventory that we made. So what is important is that we collected sources either from global monitoring or point source monitoring. And from this first global inventory, we identified that we had data for 77 CECs. So based on that and based on the data availability, and the contrasted physical chemical properties, we decided then to focus prioritization testing and development of 18 substance and a more complete review of data set for this 18 substance was then carried out, delivering average, mean, median, percentile, maximum value and limit of quantification. You can see an example of that for PFAS in soil. So that unable to see gaps also between countries. For example, for PFAS, we've noticed that we have quite extensive value for PFAS in soil for the Netherlands and the Flanders, and that wasn't really the case either for France and Wallonia. So regarding the risk-based prioritization prototype and development, what we really, as I said, we really wanted to be risk-based. So what we did, we calculated for the contaminant of emerging concern, a risk characterization ratio. This is the RCR box that you can see at the bottom, which is basically the ratio between the predicted environment concentration and the predicted no effect concentration. And to do so, we had to first evaluate the concentration of substances that we could find in the soil and the different media. So that's the fate section on the left section on the left-hand side of the scheme. So we did that in different means. We developed a fate model, which was already available as simple box, but which was adapted for soil. Using like general emission value and substance properties. We also developed a special methodology to calculate specific sources, which was a tier 2 of the FATE module, but also we could be using the occurrence data from the inventory in order to feed the concentration of substances present in different media. And then regarding the toxicity, a toxical module was built in order to derive from the substance formula toxicological value and associated predicted no effect concentration. So all that was done for the 18 pilot substances. So regarding results on estimation of contaminant of emerging concern concentration, we really use different scenarios depending on the chemicals that we were talking about. So we used 3 scenarios, one rich industrial substance scenarios for PFAS and alkyl phenol, when we from general emission value, we made a distribution over the different media. We also studied wastewater treatment pathway scenarios for pharmaceuticals and for PFAS. And we studied pesticide pathways as well as application on agricultural field. And for that, we had either a T1 or a T2 process. So on the right-hand side, you can see an example of the results. So you've got the concentration in soil for all the testing substances, which include PFAS, pesticide, pharmaceuticals, and alkyl phenol. And you can see that the ranges which are calculated are rather different depending on the substances and their properties. So some of them are very likely to be in the soil, like bisphenol A and 4-nonyl phenol, for example. Others are less likely to be in the soil, as PFHXA, for example. And on the box below describe an example and the results of T2, but I'm not going to describe that by lack of time. Regarding CC's prioritization results, so what is important to understand is that the RCR ratio, so the risk characterization ratio, was calculated for 4 endpoints. So first, we consider human receptors, either through direct consumption of groundwater or consumption of injections of crops, or either towards ecological receptors through direct ecotoxicity or secondary poisoning. So we've got graphs for each of these 4 endpoints. So you can see on the left top side results from human health and direct consumption of groundwater. So there's the results for France, the Netherlands, and Belgium. And what you can see is that PFAS have a RCR ratio which are quite low, which means that basically from the calculation that we made and with the assumption that we made, there's no real risk from PFAS through this for this endpoint. And then there was this is the blue circle, and then you've got the yellow circle having RCR value on the medium range, and for which maybe additional assessment is necessary for alkyl phenol and PFAS, and more like substances which are a bit more preoccupant are pesticide, which are at the higher range of the RCR. That means that which pose quite a strong risk for human health and direct consumption of groundwater. On the right-hand side, you've got results for comparison of prioritization for various endpoints. And in green, you have the pesticide. In gray, you've got the PFAS. In orange, you've got the pharmaceutical compounds. And in blue, the industrial. And you can see that for the different endpoints, the ranking varied a bit, but definitely the pesticide are at the higher range, and the PFAS are more at the lower range. So that was done for the Netherlands. So regarding premise impacts, we could say that we really try to maximize impacts of premise project through a strong stakeholder involvement. So to do so, we put up a stakeholder working group at the very beginning of the project, including beneficiary end users of priority results and users, potential users of the prioritization prototypes. And basically, the idea was to make sure that to design a prioritization approach useful for end users. So we had a first workshop at the beginning of the project in order to identify stakeholder demands. And the other aim was really to make sure prioritization results would be relevant for end users. So there's been like a presentation of the results to the same stakeholder group, which gave good feedback on what we did, and also draft quite a few recommendations on how we should go on the work. So, the impact, it was really important to clearly stating the modality of use of the prototype and its limitations. So I'm not going to go through all these because time is running. So as general impact of the premise project, we could say that it enabled to federate actors, so national stakeholders from the Netherlands, France, and Belgium having interest for CECs, through the building of this stakeholder working group. It enabled different EU research team of the theme on the theme of the CECs in Seoul, like the consortium of premises worked together and enable us to discover the strengths of the different teams that were involved in the project. It enabled to deliver status on CECs, either data or state of knowledge, because we asked the stakeholders their current state of knowledge as well on CECs. So we have data on that, enabling to raise awareness on CECs in soil and subsurface through workshop. We gave presentation in Answer, Aquaconsol, and Nicole, and it enables to evidence the lack of data on CECs and the need to overcome this, which was raised by the stakeholders. It's enabled to provide a risk-based prioritization approach deemed useful by stakeholders for various scales and various scenarios and for various objectives: monitoring, risk assessment, prevention, remediation, and regulation purposes. But anyhow, this work is really a first stone to further development. One-year project was quite tight, and we wish to be able to pursue it. So first, there was recommendation on the prototype itself. So I'm not going to go through all this list because I'm going to lose you. But basically, we gave recommendation on technical tool development, technical tool testing and validation. And for that, I will emphasize that we will be very keen to now go through a full-scale demonstration using large set of substances, and also to make it more user-friendly. Actually, the tool is an Excel spreadsheet, and so it will be nice to make it more friendly and more widely accessible. And as premise follow-up, we've got also general recommendation. From the inventory of occurrence data, we had quite a large sets of recommendation, like we could foresee like an inventory of the CEC data in other EU countries, in addition to the one involved in the premise project. There was a need to facilitate data inventory and compilation by harmonization of substance international signaling. A need for central storage of existing wastewater, solid, effluent, manure, compost, and digest quality data. A need for acquisition more to acquire more data, to do more prospective soil monitoring as well. Make sure that these data are collected and stored in the same place. And regarding the application, recommendation from the application of exploitation of prioritization prototype, what we didn't really have the time to do, and maybe the mean to do within premise is really to work on how the results could be transferred towards a policy instrument. We could only test substances, and we know that there was some limitation regarding the assumption as well. So we wish that we would be able to work more on that, and also to improve maybe uncertainty management. Anyhow, we think the prototype could be further developed and tested at different scale, regional, national, or European scale.
Corinne,
the connection.
To have
yeah.
questions and a short break. Could you please conclude?
Yeah, no problem. I can stop here actually. I mean, the conclusion are there, and the next slides are more for the breakout session. Just to say that premise is of course in connection with ongoing project. There's other European Green Deal initiative, like Promises Horizon 2020 projects, the Park initiative, or different R&D initiative, either on the project level or national data collection. Okay.
Thank you.